At this point, no one doubts that 2026 is the year Tesla turns things around. Again. But this time, the reason isn't a new car with gull-wing doors or fully autonomous driving. It's something much quieter, hidden inside the metal floor of a prototype in Austin. A solid block of energy made of aluminum. Yes, Elon Musk has decided to target the root of the problem that has plagued EVs for over a decade: lithium batteries. While China rushes to announce giant lithium mines in the foothills of the Himalayas, Tesla is simply erasing that element from the equation. Tesla's Texas lab looks like a secret science fiction workshop. There, engineers are testing batteries that not only bypass lithium, but also eliminate entire layers of complexity. No traditional cathodes, toxic pastes, or packaging that looks like miniature safes. The new design is so simple it's frightening. A single block of aluminum, pure and functional, that acts as both structure and conductor. It's not just pretty on paper. It's efficient, cheap, and absurdly light. The kind of thing that seems impossible until Tesla does it. And the game goes far beyond technical innovation. Geopolitics is involved. Today, most of the world's lithium passes, directly or indirectly, through China. This means that any political or trade fluctuation can affect the price of an electric car worldwide. Elon Musk seems tired of this game. By betting on aluminum, the second most abundant metal in the Earth's crust, Tesla is essentially saying, "You can keep the lithium. We've already gone further." And honestly, that changes everything. Another interesting detail is how this change is being made quietly, without fanfare, without gigantic events, without the traditional stage presentation with lights and exaggerated promises. Tesla's new aluminum-ion battery began as a whisper, but it's already reverberating like thunder in the market. Because it's not just an alternative to lithium, it's a complete reinvention of the battery concept. And the most surprising thing is that it's being built with a metal you probably have in your hands right now, holding your cell phone. But why bet on aluminum now? Because it's not just abundant. It's local, easy to recycle, lightweight, and extremely stable. Unlike lithium, which requires layers of protection due to its flammability and heat sensitivity, aluminum behaves like an athlete under pressure. It doesn't explode, it doesn't heat up unnecessarily, and it can handle a beating. This means less dead weight and fewer auxiliary systems just to prevent the battery from becoming a liability. More safety, lighter weight, and, best of all, more space for useful energy. The idea is simple: transform the battery into a part of the car's soul, not just a technical burden hidden in the floorboards. Elon doesn't just want to improve EVs. He wants the world to stop thinking of batteries as the problem and start seeing them as the solution. It's a mindset shift. And when you combine that with a lightweight, cheap, and local metal, the equation starts to make sense, even for those who've never been interested in electric cars before. What's most intriguing is that this revolution didn't emerge as a market response. It emerged as an inevitable development. With lithium costs exploding, supply chains increasingly unstable, and pressure for more affordable cars, Tesla had little choice but to innovate. But, as always, it didn't do it half-heartedly. It went straight to the root of the problem, ripping out lithium at its base and replacing it with something almost no one expected: a metal we learned to draw in school as aluminum foil. When Tesla introduced the 4680 cells, the automotive world was shocked. With promises of higher energy density, lower cost per kilowatt, and structural integration with the bodywork, it seemed the future was sealed. But 2026 arrived, and with it, a new paradigm. Suddenly, what was once a benchmark became a thing of the past. The new aluminum-ion battery, while still little understood outside technical circles, has already shown in internal tests that it can outperform the 4680 in almost every aspect. And this, without relying on a complex cylindrical design or expensive metals. Weight has always been a challenge in batteries. The 4680 cell, even with its innovations, still requires steel for protection, copper for conduction, and a heavy mix of nickel and cobalt in the cathode. Each cell is practically a miniaturized fortress. Now, imagine replacing all of this with a single piece of aluminum that does the work of all these layers without the need for external reinforcement. The result is a massive weight reduction. We're talking over 300 pounds less per pack, which translates directly into increased range and performance. But the impact isn't just physical, it's chemical too. Aluminum cells have a dramatic difference. Each aluminum atom carries 3 electrons, while lithium only carries 1. This completely changes the mathematics of energy density. While lithium struggles to reach 180 dWh in real-world conditions, tests with aluminum ion have already achieved between 200 and 300 dWh. This means more energy in the same volume, or the same range, with a much smaller battery. And in the world of EVs, every pound saved counts. Another area where aluminum batteries shine is their design simplicity. The 4680 still requires a complex cell stacking architecture, thermal management systems, sensors, and cables. The new single-block design eliminates much of this. Fewer moving parts, fewer components, less chance of failure. Tesla can even apply this directly to the Giga casting process, integrating the battery into the chassis in an unprecedented way. It's as if the car itself becomes the battery. The structure also changes the game for maintenance and production. While the 4680 cell requires welding, precise assembly, and individual integrity testing, the aluminum block can be molded and tested as a single unit. This saves time, reduces failures, and speeds up the production line, not to mention the savings on rare materials. By eliminating nickel, cobalt, and graphite, Tesla positions itself more sustainably and is less vulnerable to the international market. Perhaps what's most impressive is how this new battery reverses what once seemed non-negotiable. Previously, it was thought that to increase energy, one would have to accept more weight and complexity. Now, the equation has been turned upside down. More energy comes precisely from lightness and simplicity. It's a counterintuitive concept at first glance, but absolutely logical when analyzing the atomic behavior of aluminum and its conductive structure. Of course, the 4680 still has its place, especially in larger models or in markets where the transition to aluminum may take time. But what we're seeing is the birth of a new standard. And if Tesla can scale up production, which it's already begun to do discreetly in Texas and Nevada, entry-level models will likely abandon the cylindrical design entirely. The Model 2, for example, is practically designed to be the first to incorporate this leap. Safety has always been the Achilles heel of lithium batteries. While Tesla has made significant strides in thermal management and short-circuit protection, the truth is that every lithium battery is, at its core, a box of risks waiting for the wrong conditions to happen. The main culprit is called dendrites, tiny filaments that grow inside the cell and can cause catastrophic short circuits. The combination of flammable electrolytes and fragile internal structures turns any failure into a potential fireball. And with vehicles becoming increasingly powerful, this is a detail no one wants to ignore. Now comes aluminum ion with an almost Zen-like approach. No dendrites, no volatile solvents, no mandatory liquid cooling. Instead of using flammable liquids, these new batteries utilize ionic salt electrolytes, a dense, stable, and non-flammable compound. And best of all, it remains functional at temperatures that would easily exceed 200 Celsius, while lithium batteries would already be screaming for help at 80 Celsius. It's like replacing a bare wire with a factory-shielded cable. Without the need for piping, cooling pads, or thick separators, the aluminum battery eliminates between 70 and 80 kilos of structural weight in containment systems alone. That's a lot, but more than that, it's a complete reconfiguration of the idea of safety in electric vehicles. Tesla can now design its cars with the battery as something inherently reliable, no longer a controlled threat. This opens the door to thinner, lighter, and even more creative designs. If we think about it, this also changes the user experience. Today, many EV drivers still have a certain fear. Can extreme heat affect the battery? Can a side-on accident cause a fire? With aluminum ion, these questions begin to lose their meaning. Tests show that even under stress, the system remains stable, without generating uncontrolled heat or releasing toxic gases. The chance of an accidental explosion simply disappears. And that, let's face it, is something that puts any family's mind at ease. Another interesting point is that this new chemistry doesn't suffer from the so-called hotspot effect, localized points of intense heat during fast charging. Lithium batteries need to slow down after 80% to avoid this problem, which creates the feeling that the last 20% takes forever. With aluminum, this bottleneck disappears. Charging can continue at high power until the end without the risk of overheating. And this, in addition to greater safety, means more practicality in everyday life. From a technical standpoint, this thermal stability also reduces the need for sensors, controllers, chips, and safety valves. Fewer parts, fewer failures, less maintenance. Tesla is clearly betting on an approach where trust in the material replaces excessive digital protection. A concept very reminiscent of classical engineering. First, choose the right materials. Then, design something simple and solid. It sounds old-fashioned, but that's precisely what makes this innovation so revolutionary. And the most curious thing? This kind of stability even allows it to operate in extreme environments. Imagine an electric car driving in the heat of Nevada, the cold of Alaska, or the tropical rains of Brazil, all without losing performance and without needing additional battery cooling systems. The new technology not only holds up, but seems to thrive on being challenged. It's as if it were born for this. One of the biggest changes this new battery brings goes far beyond chemistry or safety. It completely transforms the way a car is assembled. Until recently, the logic was simple. You designed the car, then figured out where to put the battery pack. But with aluminum ion, Tesla is doing the opposite. Now, the battery is no longer a component inserted into the vehicle, but rather part of the car's body itself, literally. And this is made possible thanks to the Giga press, the monstrous 50,000-ton press that molds the chassis into single blocks. With the new architecture, Tesla no longer needs to stack hundreds of cylindrical cells and then fit them into a reinforced steel case. The aluminum block can be cast as a single, thin piece, which then serves as the vehicle's structural base. This reduces the number of screws, welds, and fasteners, reducing noise, vibration, and even assembly time. The car's rigidity improves, production speeds up, and costs plummet. It's a quiet revolution happening right there on the factory floor. This new type of structural integration brings a number of practical benefits that perhaps not everyone immediately notices. First, weight savings. By eliminating the protective housing, covers, supports, and dividers that existed in the previous architecture, Tesla manages to shave about 88 pounds off the bodywork alone. And that's no small feat. Every pound lost in an EV can translate into more range, more agility, or even more interior space. Furthermore, the design is cleaner. There's no longer that false floor that most electric cars have. The car's floor becomes the actual floor. And because it's precision molded from high-strength aluminum, it doesn't compromise impact safety. On the contrary, it acts as an ultralight roll cage. It's as if the car's skeleton were already powered. Interestingly, this approach also facilitates future repairs or upgrades, since the battery is no longer locked inside sealed compartments. Another advantage worth mentioning is space. By fusing the battery directly to the chassis, Tesla frees up space in other parts of the car that previously needed to be reserved for ducts, cooling systems, and protective structures. This can translate into more passenger space a larger trunk, or even new smart compartments. A vehicle with this type of battery can be redesigned from the ground up, with a freedom that previous platforms never allowed. This also helps explain why the Model 2 was designed from the outset with this new logic in mind. It's not just a cheaper model from Tesla. It's a completely redesigned platform to take full advantage of the new battery. And so, it manages to be compact without losing range, affordable without sacrificing safety, and efficient without needing gimmicks. All of this is due to the fact that the battery is now more than a power source. It's the car's structural foundation. The manufacturing process also benefits enormously from this integration. With fewer parts to assemble, fewer robots are needed on the production line. This means smaller factories can produce more cars, faster, and with fewer errors. And for an ambitious plan like Tesla's, which aims to deliver millions of Model 2s in the coming years, this optimization is essential. It's not just about innovation, but about scale. For years, battery cost was the biggest obstacle to truly affordable electric cars. No matter how efficient the engine or the aerodynamic design, the final price always came with the hefty price tag of lithium, nickel, and cobalt. Now, with aluminum-ion entering the scene, this math is truly starting to change. And best of all, it's changing in the consumer's favor. After all, aluminum is the second most abundant metal in the Earth's crust. In the United States alone, there are over 300 million tons of natural reserves ripe for exploration. And best of all, without relying on routes controlled by foreign governments. By switching from lithium to aluminum, Tesla not only avoids the instability of the Asian market, but also eliminates much of its import costs. Just remember that over 60% of lithium is refined in China, which forces manufacturers to pay expensive shipping, customs fees, and deal with unpredictable bureaucracy. With aluminum, everything changes. The raw material can be mined in Arkansas, refined in Texas, and assembled in Nevada, all on American soil. And when Elon Musk talks about energy independence, this is what he's talking about. The numbers don't lie. Until last year, a 4680 lithium battery pack cost around $8,600 per unit. With the new aluminum battery, that cost has dropped to approximately $3,900. That alone represents a reduction of almost $4,700 per car. This, combined with savings on welding, bolts, structures, and labor, represents a true game changer. And it's not just a matter of saving money. It's a strategy that allows you to lower the final price of the car without sacrificing quality. And here comes Elon Musk's bold plan. Launch the Model 2 priced below $25,000. It may seem crazy in times of global inflation and high interest rates, but the secret lies precisely in these cost reductions. By cutting almost half the price of the battery, the car's most expensive component, Tesla is able to offer a complete, technological, and efficient vehicle at a price previously only seen in compact combustion-powered cars. And we haven't even mentioned the incentives yet. With the $7,500 tax credit offered by the U.S. government, combined with Tesla's occasional end-of-quarter promotions, which sometimes discount an additional $1,000 to $2,000, the Model 2's final price could drop to around $11,500. That's right, a state-of-the-art electric car for a price that, let's face it, feels like paying for a cell phone in 36 installments. And this completely changes the game for millions of Americans who dream of owning an EV but found the prices prohibitive. This breakthrough isn't just Tesla's achievement. It's a blow to the traditional automotive industry. While other automakers still struggle to make their entry-level electric models viable, relying on expensive batteries and rigid processes, Tesla has simply skipped steps. By mastering everything from mining to assembly, it has created a verticalized supply chain that virtually immunizes it against supply crises and price fluctuations. That's why aluminum is being referred to behind the scenes as Tesla's new oil. Not because of scarcity, but because of its strategic importance. By having direct access to a local, lightweight, abundant and recyclable raw material,